Hi, good morning, everybody. Thank you for joining. My name is Chandra Salem, and I'm an enterprise architect at Rackspace. My team and I specialize in implementing Hadoop projects for some of our customers here at Rackspace. And we are hoping to share some of the knowledge and the experience that we've gleaned from our Hadoop journey at Rackspace, and we hope that you will find this very useful. We also encourage you to submit any questions you have regarding today's presentation, and even if we cannot answer most of them today, we'll definitely try to answer them offline, and we'll try to send you the responses via email. And also, we have a couple of poll questions that at some point during the presentation I will be I'll be kindly requesting you to fill out. And also, please feel free to give any qualitative feedback, and also feel free to provide any rating that you think is that applies to this presentation. And one other quick housekeeping point is the presentation for today is also available as a PDF attachment. In case you find that the fonts or some of the graphics are small, by all means, we encourage you to download the attachment and in the PDF format and follow along. Thank you very much, and let's get started. So today's theme is essentially simplifying data management using Hadoop. As you all know, and given the very varied profile of the audience, we all know that Hadoop is a very highly technical area, and there are a lot of interrelated components that might seem daunting for corporations that are just starting their Hadoop journey. In most of the Hadoop implementations, there are different stakeholders with totally different areas of concerns. There are infrastructure administrators, the security policy administrators, application developers, operators. These are just examples of some of the profiles in a typical Hadoop project from a stakeholder perspective. Our goal today here is to illustrate how the Hadoop landscape is getting mature, and regardless of what your area of concern within the Hadoop world might be, the Hadoop distributions have evolved in such a way that even the most complex areas that were previously very hard to manage have gotten much easier. And also from a software perspective, our focus today will largely be on Horton Data Platform's version of Hadoop, which is HDP 2.2. That is the latest version. We chose Horton Data Platform because we feel that is the most open source friendly distribution of Hadoop today. That is not to say that Matter or Cloudera, the other popular Hadoop distributions, would handle these concerns differently. So what we talk about today with regards to the Hadoop software is largely applicable and portable across other Hadoop distributions as well. So the theme for today is we are going to start with giving you a very compact overview of Hadoop, what Hadoop is and what it is not, and briefly talk about the history of Hadoop. And then we are also going to dive into what typically are the key areas of concern in modern day data management. This is not specific to Hadoop, but this is more data management from an organizational perspective, regardless of whether you use traditional relational databases or whether you use Hadoop or any type of NoSQL solution. All of these areas of concerns are common denominators, regardless of what the underlying data technology is. And then we are going to quickly see, using Hadoop 2.x, Horton Data Platform 2.2, how Hadoop handles these areas of concern. And then we are also going to address each of the operational scenarios and the areas of concerns one by one, and we are going to get into some level of technical detail into how Hadoop attempts to solve all of them. And finally, for customers and for some of the attendees that are starting their Hadoop journey, we also want to give a quick look ahead to what would be the most logical steps to take, and how do you start small and scale as you grow. So we want to make the whole process simply. We want to bring our insights in the simplification of the whole Hadoop journey, all the way from choosing software and getting down into the specific software aspects, the infrastructure aspects, and the actual migration itself. And finally, we are also going to talk about where Rackspace can help, because we help a lot of customers at various levels of maturity when it comes to Hadoop, and the insights that we have gathered from such implementations, we will be more than happy to pass on to you. Now, we are going to briefly talk about the history of big data. What is Hadoop and how, what was the primary driver behind the evolution of Hadoop? So Hadoop was initially designed as a platform to store and process large volumes of data that came in at unpredictable speeds. The volumes and the variety and the velocity were often referred to as the 3 Vs, and these were beyond the capacity of existing storage systems, both from a storage perspective and from a data processing perspective. So when you look at all relational databases that were capable of, that were designed to handle perhaps hundreds of gigabytes of data, were not scaled or not built from the ground up to handle tens of terabytes of data coming in every day from various heterogeneous sources. It's not just the storage and the compute platform, but all of the security frameworks and the whole ecosystem. The operational tools were also not ready to handle data that came in with different structures and at different speeds from various different sources. So Hadoop was the solution that initially attempted to solve the problem with huge volumes of data that had a very heterogeneous variety. And Hadoop primarily has two main components. One is the storage component, which is called HDFS, the Hadoop Distributed File System. That essentially split the storage across many servers. It horizontally scaled and stored the data across many commodity servers. The underlying assumption with Hadoop was since the use of Hadoop was on commodity servers and the scaling was done horizontally, the underlying and a critical assumption with Hadoop was that commodity hardware can and will fail. So unlike traditional SAN systems where data resiliency and data redundancy was built in at the infrastructure and a storage level, Hadoop Hadoop manages data redundancy and data distribution at a software level. So for example, every block of data is replicated 3 times across 3 different servers. So even if one node goes down, the data never gets lost. And then in addition to storing data, it is not enough if you store large volumes of data. You also have to find a way to process the large volumes of data in a reasonably quick amount of time. And so the data processing framework in the older version of Hadoop, which was in fact I would say as late as last year, as late as the early part of last year, was MapReduce. MapReduce was the de facto framework to mine data out of HDFS, and MapReduce was very hard to use. And in addition to MapReduce itself being hard to use, the typical application developers, in addition to writing the logic to mine data, they also had to write logic to manage the cluster's resources and how the task was coordinated and the task was distributed across all these servers. That was a very complex task, and most of the application developers were data scientists, and there was definitely a gap in terms of skill sets. Fortunately, Hadoop 2.0, which simplified a lot of things very easily. So MapReduce no longer was the sole and the de facto standard for processing data stored in Hadoop. Yarn, which is the nerve center of modern day Hadoop, sort of became the de facto data operating system and the nerve center. And Yarn, as such, extended Hadoop's data processing capabilities from MapReduce into multiple programming frameworks and provided the capability to handle frameworks such as streaming and real-time analytics, in-memory processing. All of a sudden, Hadoop no longer became accessible only. The HDFS data no longer became accessible only via HDFS. You could also process streaming data. You could do real-time in-memory analytics and so on and so forth. So on this slide, we just want to quickly give you a comparative view of how RDBMS addresses scaling and how Hadoop addresses scaling, right, from a storage perspective. So when you look at RDBMS, you can scale the application and the web tier, the application and the client tier horizontally. But when it comes to database, right, you're going to hit a point of diminishing returns. There is only a certain extent to which you can vertically scale the underlying database itself in terms of memory and storage and whatnot. you hit a point of diminishing returns, and even if the platform itself is perfectly scaled vertically and perfectly optimized, the existing legacy technologies, the relational database technologies, were not built to handle hundreds of terabytes of data. So you get into problems with indexing and the applications, and the applications were not exactly designed from the ground up to deal with larger volumes of data. Now, when you look at the basic tenets of Hadoop in contrast with relational databases, Hadoop essentially scales out data and storage. So by adding cheap commodity servers that are expected to fail, you can scale the data tier also. So the traditional constraints that you had with legacy RDBMSs are mitigated by horizontally scaling, or we call it the scale out. And one thing with Hadoop, right, even if you scale the storage tier, it was always expensive to move the data from the storage layer into the processing layer. So Hadoop felt that it was easier to move compute closer to data rather than moving data closer to compute, given all the network constraints and the sheer volume of data. So these are essentially the fundamental differences between Hadoop and traditional legacy relational databases. So we just kind of wanted to sort of give a very 10,000 feet view of what is Hadoop and what is the, how does it compare or contrast with existing legacy technologies. Now, moving on to the main theme of the presentation, right? So when you're in the early stages of your Hadoop journey, actually regardless of where you are in your Hadoop journey, right? The Hadoop users typically have the key technical stakeholders in any Hadoop project have different roles and different profiles and different areas of concerns. And we actually broke down, this slide actually breaks down the areas of concerns into 5 silos. 5, I would say at this point, mutually exclusive silos. One is infrastructure. What is the right-sized infrastructure for Hadoop? What are the right deployment models? So this would typically be the main areas of concerns if you're a systems administrator or an enterprise infrastructure architect. And the next one is operations. So when you look at any data management platform, right, things like how do you scale? How do you scale a cluster or a database system when you have a high amount of traffic is of paramount importance. Likewise, there has to be solutions to address disaster recovery and backup and replication scenarios. Also, there has to be a fairly intuitive and a well-defined way to monitor the health of your Hadoop platform or any database platform for that matter. And the next one, perhaps the most important one, is security and data governance. So just like your traditional legacy databases, right, the data is the most valuable asset any organization has. So how do you secure the data? Given that Hadoop is meant to consolidate and aggregate data from multiple sources, on the sources itself, we do not have very granular control. Unlike traditional legacy applications or web applications, you have very well-defined points of control and access control. With Hadoop, you would actually have it would be somewhat different. Because the data, you have no idea as to where the data is coming from. So you want to put controls around how do you secure the data once they make it into Hadoop. And the next one is application development, right? With RDBMS, it was very straightforward. With traditional legacy databases, most of the de facto interface to interact with the databases was structured query language. And then from an application development perspective, most of the enterprises were either ERP customers or they used Java or some variation of .NET. So the number of APIs that actually access the data was very well defined. Whereas with Hadoop, you're looking with very heterogeneous sources of data. You have log data that forms a large chunk of what Hadoop is capable of processing. You also have semi-structured data, structured data, mobile data, and so forth. So Hadoop has specific programming models that are built from the ground up to handle specific types of data, and we'll be covering it. And finally, Hadoop or any database system cannot exist in a silo. It has to essentially integrate with ETL tools, with existing visualization and business intelligence tools. And also, the support has to extend beyond, unlike databases, which had to just comply with SQL support. Hadoop had to extend to multiple programming languages, Python, Java, and something that, closely resembles SQL at least. And also the language that is very popular with data scientists, which is the R programming language. So now that we have seen the high-level areas, right, we are going to give you a quick sneak peek on the actual software components within the Horton Data Platform 2.2 that addresses each of these operational areas. This is going to be a very brief summary before we dive into the more granular aspects of it. So here is how Horton, any Hadoop distribution, and what we see here is Horton Data Platform. How does Horton Data Platform handle the multiple areas of concerns that we just saw in the that we just discussed in the previous slide? There is, there is the actual data processing, which we depicted as application development in the previous one. As you can see, there is MapReduce, there is Spark, there is Solr for search. These are purpose-built APIs to handle one particular type of application workload. And also, there was a security aspect of it. As we saw on the previous slide, security is a separate area of concern, not necessarily tied to the application development. And this is basically the components that Horton supports. And we'll be talking about it more in length at the, the coming slides. And then the operational scenarios that we talked about. How do you keep the cluster, running in good health, and how do you monitor the state of the cluster? For that, Horton Data Platform has specific APIs that are tabled under operations in this slide. And then finally, data governance. Given that the sources of data is going to be very diverse and very disparate, there are specific APIs that are built from the ground up to handle specific types of data coming into the Hadoop cluster. So now, let's talk about, now there is a different view of Hadoop from a technical, from a programming and from an API perspective. As we mentioned in the first slide, Hadoop is not a singular technology. It is a platform that is made up of several subcomponents, which may or may not be mutually exclusive. But the goal is they are all operating. The common denominator is the data is sitting on the HDFS layer. The storage tier is HDFS, and regardless of what your area of concern is, securing the data on the HDFS tier or extracting data from HDFS is a common denominator. That said, we have actually broken down from an application perspective, from a data lifecycle perspective, the Hadoop ecosystem into the following 6 silos. The first one is data ingestion. How do you ingest data into Hadoop? So when you look at data ingestions, right, as with any data warehouse or as with any analytics solution, you're going to interact typically with one or more relational databases or ERP that has a relational database behind the scene. So relational database is extremely important from a enterprise data landscape. So Hadoop has simplified. In the past, you had to the programming to get the data from Hadoop from one of the RDBMSs into the Hadoop cluster was not easy. But now there is a very robust and a stable API called Scoop, which stands for SQL to Hadoop. That is the de facto interface to move data from a relational data store into Hadoop and from a Hadoop cluster to relational database. This is it's a standardized JDBC type operation, and most of the ETL tools, the commercial ETL tools, essentially implement Scoop behind the scenes. So it's a well-defined and a fairly easy to use API that simplifies the task of moving data from relational databases into Hadoop. The next one is Flume. So log data, right? Be it web logs or data from Common Crawl and third-party e-commerce sites that actually tracks customers, web click-throughs and web logs, and also system logs in case you're looking at in case you're looking at server statistics to glean some insights into data. The de facto source of such data is logs. So when you're looking at logs that potentially run into tens or 20, tens and perhaps even hundreds of terabytes daily, you want to come up with a framework that is purpose-built to aggregate and easily push the logs into Hadoop. So the de facto API for that is Flume. And then the real-time messages, right? These are one-off real-time transactions that come. They are very small messages, but they are more event-based. You can even think of a Twitter feed as something that is real time, or if you're running an Internet of Things type project, some data from sensor that comes in. in a very hard to predictable interval into your Hadoop cluster would be a real-time messaging. For that, one of the standards, one of the more popular standards that's supported by Hortonworks out of the box is called Kafka, which is a distributed messaging layer. You can think of it very similar to JMS or Microsoft, MSMQ. And then the actual data processing itself, right? So the data ingestion layer concerned simplified how you got the data from diverse sources into your Hadoop cluster. The next one was how do you process data? Again, we broke it down into the four common themes or four common areas. One of them is Hive. So coming from the analytics world, right? If you are a business intelligence person or if you're a data analyst, you want a data warehouse-like scenario, a data warehouse-like platform to easily mine data using something that looks like SQL. So Hive is one of the more mature Hadoop data warehousing framework that lets you mine data using a SQL-like interface. And the next one is HBase. Hadoop Hive is more for batch analytics, and there is a little bit of a latency in the time the data makes it into your Hadoop cluster or the time you submit a query to the time you get a response. HBase, on the other hand, uses HDFS data, but it is meant for real-time, super fast reads and writes. So if you want to get the data that is sitting on your HDFS data, which could be potentially tens of terabytes or hundreds of terabytes, if you want to get it, if you want to process the data interactively and rapidly, HBase is the out-of-the-box Hadoop NoSQL store for real-time and fast interactive access. And the next one is Spark. So when you look at a typical Hadoop cluster, right, the number of nodes span anywhere from tens to hundreds of servers that service data nodes in Hadoop, or these are the actual processing units in Hadoop. Spark is actually in memory. So instead of relying on the relatively slower response times that you get from SAS and SATA drives, in-memory analytics makes the data access from the HDFS data much faster. And Spark is the de facto in-memory platform across all Hadoop distributions. Additionally, Spark is actually an alternative. A lot of people look at Spark as an alternative to MapReduce. And Spark has also got some purpose-built algorithms, such as machine learning, graph users, and they all, graph database scenarios. It's called Spark MLib, Spark Graphics. And also Spark has purpose-built APIs for processing streaming data. Again, it simplifies by creating predefined APIs that are built from the ground up to handle common data processing scenarios. There is very little discovery to be done in terms of incorporating new data processing models. And finally, Storm. Apache Storm is one example of how you process streaming data real time. So Kafka and Storm typically are paired together. Kafka pushes the message into the Hadoop cluster, and Storm intercepts the messages coming from Kafka, and they either choose to persist the data in HDFS or it chooses to interact real time with the customer. And then there is also security. The security is handled at a coarse-grained and a fine-grained format by two security frameworks called Apache Knox and Apache Ranger. And finally, the operations itself, right? There is Ambari, which is basically a cluster management tool that lets you deploy the appropriate Hadoop components on the appropriate server. Given that there's a large number of servers in a Hadoop cluster, these are very important. Tools in order for you to manage the Hadoop cluster in a fairly easy way. And the underlying glue is Yarn, which is the data operating system, and HDFS is the common denominator. That is the storage tier. Moving on to the main area of concern, right, is infrastructure. When people talk about infrastructure on Hadoop, right, there are various deployment models. So these are the more popular ones that you're seeing on the screen. One is Hadoop as a service. I'm not going to go through each and every, I'm not going to read through this wordy line. You can refer to your attachment. That said, right, Hadoop as a service is basically a black box Hadoop, where the software and the infrastructure tier is bundled. Some of the examples are Amazon EMR and Azure HD Insight and Rackspace Cloud Big Data, where you can rapidly provision a Hadoop cluster in minutes and start doing your application development in 10 to 15 minutes after spinning the cluster. And then Hadoop on public cloud infrastructure, which is very similar to on-prem full a full stack installation of Hadoop, but the underlying infrastructure would be elastic and, on servers such as Rackspace cloud servers on Amazon EC2. And then the other one, which we think is the most popular one based on what we have seen at Rackspace, is bare metal. Bare metal gives by far the most superior performance when it comes to all of the Hadoop infrastructure flavors. And then the other one is if your enterprise has a private cloud and you want to incorporate or you want to integrate Hadoop into your private cloud infrastructure, that is also, Hadoop can also be deployed on private clouds such as, OpenStack, for example. So, and then now coming back to the operations, right? So as we talked about, there are three main areas of concern when it comes to operating a Hadoop cluster. The first one is the cluster health monitoring. And the reason why you see the two graphics is I wanted to show you how easy, how simple Ambari Web is to, the UI is so simple, it's very intuitive. So monitoring something like 200 or 300 clusters, a fairly large Hadoop cluster, has been greatly simplified by using Ambari Web Console. So the point of the graphics is just to show you how intuitive and how easy and how less cryptic, I would say, the UI to monitor a Hadoop cluster is. And then from a scaling perspective, scaling Hadoop is really easy. Simply by adding data nodes, right, by adding commodity servers as additional nodes, you linearly scale both the storage and the throughput. So again, that is one of the concerns with Oracle and IBM and some of the legacy database technologies. Scaling is not that easy. With Hadoop, the more servers you add, the more linearly you scale. And then DR and replication, right? DR and duplication is disaster recovery and replication in Hadoop is very different from how you would do in relational databases. Simply because we are looking at extremely large volumes of data, right? It might not be cost effective for us to clone the data across three or four different external sites or even SAN, because it's going to be extremely cost prohibitive. So Apache, Horton Data Platform, has something called it's got a purpose-built API called Apache Falcon that essentially gives you some standard frameworks and tools and utilities that will let you back up the most relevant data. So if you have 100 terabytes of raw data, when you're done with the actual data processing, right, only 1 or 2 terabytes of data might be relevant and might be considered pristine that you want to back up. Additionally, the raw data itself, given the fact that it's replicated 3 times, there is some level of redundancy built into the Hadoop cluster itself. So there is no need for you to back up and snapshot, every byte or every kilobyte of data. So the replication aspect is quite different from Hadoop as compared to RDBMS. And the summary is Apache Falcon and a few other utilities such as DistCP and HDFS Snapshot makes it easy for you to achieve your backup and recovery objectives without having to replicate the infrastructure 10 or 15 times over. Now let's talk about security, right? So there is the perimeter security, which is your authentication. So Hadoop provides a framework called Apache Knox, which controls access to the Hadoop perimeter itself. And this tool integrates very well with the single sign-on or the IDM solutions that your enterprise has. In fact, we see a lot of customers at Rackspace that integrate the Hadoop authentication mechanism with their existing single sign-on Active Directory or LDAP, so that it's always the security frameworks they have at an enterprise level applies to Hadoop as well. And then the next one is Apache Ranger. Apache Ranger provides data level and more granular security. Think of Apache language, if you're coming from the legacy RDBMS world, you can think of Ranger as equivalent to your alter and your grant and your revoke statements. So, and again, I illustrated the web console for Ranger on the screen to show you how intuitive and how simple the framework is. And the reason I keep calling this out is because, as late as the start of last year, right, none of the framework that you see, none of the screens that you see on my screen existed. So it is now it's simplified to a point where it's no longer, you no longer have to, work with shell scripts, and you no longer have to work with, it's no longer programmatic. It's all UI driven. No matter how complex the actual data storage tier is, these tools actually abstract the complexity of security management using simple user-defined, user-driven APIs. And then encryption, right? If you're an e-commerce customer, and especially if you're considering deploying your Hadoop cluster on an off-prem data center, perhaps with a cloud provider, or even if you go with a Hadoop as a service model, you definitely would want to think about encryption at some point if you're a customer that is bound by regulatory requirements and whatnot. So wire encryption is available out of the box. Any HTTP interfaces into the Hadoop cluster is available out of the box with Hadoop's built-in wire encryption. And at-rest data encryption, given that you're essentially trying to encrypt, perhaps hundreds and tens or hundreds of servers, the sheer volume of data and considering the trade-off between encrypting, decrypting, and the sheer volume of data, data at rest encryption is not available out of the box with Hadoop. But for customers that are very security and compliance bound, there are a lot of leading technologies. Some of the examples that we have worked with at Rackspace are Protectity and Wallmetric that encrypt and transparently decrypt the entire cluster, the Hadoop cluster, in such a way that it's transparent to the applications. And also, right, from an application development perspective, again, this is really where Hadoop, this is one of the main reasons why a lot of, beyond the 3 Vs, this is one of the main reasons why a lot of customers are moving to Hadoop. So, in addition to being able to process batch analytics using MapReduce and Hive, Hadoop has purpose-built frameworks and purpose-built APIs to process streaming data. Some of the examples that you see here are Kafka, Storm, and Spark. And the other more popular, the emerging language, one of the most popular frameworks for Hadoop is predictive learning and machine learning, predictive analytics and machine learning. And Hadoop has a lot of support for the R language. The open source CRAN version of R supports the R language support within the Hadoop cluster. And then there is Spark MLib, which has pre-built machine learning algorithms, statistical algorithms that work, that operate on top of HDFS data. And then there is also Mahout, which is again a very mature machine learning language. So you don't have to write custom programs to do a statistical, statistical processing such as logistic regression. The APIs are already there and they are developed in such a way that they are ready to plug in to your HDFS data. And finally, as I mentioned, SQL and NoSQL interfaces, right, are extremely important. So SQL is the de facto, the most popular data processing language in the world, and any data management platform without SQL would not meet the full requirements, right? So that said, Hadoop has multiple options to run SQL interfaces on top of your Hadoop data. HBase provides a NoSQL platform, and there is a project in Horton Data Platform called Apache Phoenix, which actually provides a SQL skin over HBase data. So even though the underlying data is in HDFS and HBase, you work with the data as though it was just another relational database. And also there are third-party tools such as Actian, Splice Machine, and so forth that have that leverage the scalability of Hadoop from a HDFS perspective, but from a real-time and from a processing and from a ease of use and a language familiarity perspective, they implement SQL, and it's almost real-time. It's near real-time, but based on HDFS data. Updates and inserts, things that are not possible with traditional Hadoop and MapReduce are made possible with tools such as Actian and Splice Machine. And then Spark SQL is a very, very fast alternative to Hive. It works very well with, it's got JSON support, and it works very well with JDBC driver. So if you have a program or a job that needs to join a relational database on one side, and also you want to join the relational database data with data sitting in Hadoop, Spark SQL would be a very fast way to do this. And finally, we talked about the data ingestion. That is also an extension of application development. That is Apache Scoop and Apache Flume, as we talked about before. And then finally, right, one of the other areas of concern was how does Hadoop integrate with the rest of the enterprise ecosystem? So when you look at typical enterprise, some of the typical enterprise ecosystems, right, there are 4 key areas. One is they have an ETL tool. Since there are multiple databases, you want to come up with an effective way to move data around seamlessly. So most of the leading ETL tools have Hadoop, built-in Hadoop support that run natively on Hadoop. I've just displayed some of the examples. The other one is visualization. How do you visualize the data that is on Hadoop, your federated reporting and your executive dashboards and your BI reports. So MicroStrategy, Tableau, all of them have built-in support for Hadoop. The next one is analytics. How do you do predictive mining, predictive analytics, data discovery? All of the more popular software available today have full support for Hadoop, and also all of these databases, Elasticsearch, MongoDB, they all have connectors to Hadoop so that Hadoop can coexist. Hadoop can be the data lake, the place for data coming from any number of diverse data sources. And then finally, how do you plan your Hadoop implementation? So a lot of, at Rackspace, we see a lot of customers that simply choose Hadoop, whether or not Hadoop meets their requirements. So Hadoop is not, it's not a one-size-fit-all, and Hadoop is not a silver bullet that solves all of data warehousing or all of analytics needs. There are certain use cases to which Hadoop may not be the answer. There might be, there might be better solutions, and there might be, cases where Hadoop works better than a relational databases. So what we at Rackspace advise customers is we basically advise customers to take a 7-step approach. First is look at your use case very closely. Start small. Make sure that Hadoop is indeed the right solution. Hadoop or one of the components in Hadoop. Using any one of the silos that we discussed before. And then depending upon, your security and your data isolation requirements, determine what is the right deployment model. Do you want to run Hadoop as a service on Hadoop as a service, or do you want to run Hadoop on public cloud infrastructure? Do you want dedicated Hadoop? So that would be the next important choice you make. And then the next one is designing a cluster. The number of servers, what should be the memory, what should be the disks, what should be the storage configuration and so forth. And these are the top three are the high-level infrastructure ones, and then you move on to the actual application itself, design your security model. Since you're looking at different sources of data, you need to put some fences and some guardrails around who gets to access what data. So you do your governance security, and then finally you talk about integrating Hadoop with the rest of the enterprise, which in a lot of cases would involve decommissioning some aspects of your enterprise data warehouse itself. And finally, I wanted to show you, based on our experience at Rackspace, right? What does the post Hadoop implementation world looks like? So this slide shows you in the pre-Hadoop world, without Hadoop, all of the data warehousing, all of the analytics was done on a centralized data warehouse tier. The data warehouse was often the system of record, the system of truth. So in the Hadoop world, right, we always recommend customers to complement Hadoop with the existing data warehouse. You still want to leverage the SQL support and the existing tooling that you spent years building over an enterprise data warehouse, but at the same time you want to offload some of the the storage operations to Hadoop, so you get cheaper storage per terabyte. So we definitely want to call out that the enterprise data warehouse is absolutely still relevant, and even with the advent of Hadoop, enterprise data warehouse has strengths that simply cannot be replaced with Hadoop. And then now that we've talked about Hadoop, right, this is the last slide in the presentation. And when you look at Hadoop, right, as we discussed, there is the software aspects, there is the infrastructure aspects, and there is the actual deployment model. So in order for you to have an effective Hadoop partner, you need to be at the intersection of all three. You need to know what would be the right way to size your Hadoop from a bare metal perspective, what would be the right cloud models, and what would be the software aspects, such as NOx and such as the security frameworks and the actual data processing frameworks, because each of your use cases have a different implementation of software. So we believe at Rackspace, we are probably at Rackspace, we believe we are at the intersection of all of the three critical areas that that are needed to be a very successful Hadoop implementation partner. And we have multiple, regardless of what your chosen deployment model is and your data isolation needs are. We have Cloud Big Data Platform, which is a multi-tenant Hadoop model as a service, provisioning done in 10 minutes, ready to code right off the bat. The next one is Managed Big Data Platform. These are single-tenant Hadoop platforms. If your emphasis is on performance and data isolation, Managed Big Data Platform is the way to go. And then all of our Hadoop offerings are powered by Hortonworks Hadoop HTTP data platform. So this is the true open source distribution in the market. There is Cloudera and MapR, and we believe at this point Hortonworks is the true open source version of Hadoop. So that concludes my presentation for now, and I'm going to move on to some of the questions that I received. Why wouldn't I consume Redshift for my big data analytics? The bottom line is you can, but Redshift, right, there are two reasons. One main reason is Redshift expects you to define a schema. You need to model your databases in advance. So Redshift in that way is not any different from something like Oracle or SQL Server. But when you get data that you do not know what the format of the data is going to be, then Redshift cannot work because you're getting data that does not conform to your schema. So Redshift is a data warehousing solution that requires schema to be defined in advance. Whereas if you want to use Hadoop as a data lake, you can take the data as it comes in, and you can deal with the variety of data at the application tier. And then, how do you see the next 3 years playing out for Hadoop? Personally, we think at Rackspace, and I think most of the industry experts agree, Hadoop is going to become the de facto analytics and let me actually simplify the answer, right? Today, this is my opinion, and I share it with some of my Hadoop evangelists. When you look at today, when you talk about what are the top 3 databases, people say it's Oracle, SQL Server, and DB2. What are the top 3 data warehouses? They always say, Netezza, Teradata, perhaps. 3 years from now, when people say what is the data management platform, you're going to essentially talk Hadoop distributions. You're going to talk about Rackspace Cloud Big Data, Horton Data Platform, Hadoop. I think Hadoop is actually becoming the the de facto ubiquitous data tier that addresses storage as well as the programming frameworks in ways that RDBMS could not do it. And then, will Sharp be replaced by Spark SQL? Yes, the answer is yes. Spark SQL is already, I believe even AmpLabs have stopped supporting Sharp, and they're moving on to Spark SQL. Why? And then finally, why are you so handsome? Thank you for the question. I wish I knew. How do you need to back up Hadoop given the 3x replication? The answer is no. You want to back up in case you do some data summarizations that you believe is pristine. You want to back up the summarized data and the source data, but the actual raw data itself for disaster recovery purposes, as you mentioned, are replicated 3 times in a Hadoop cluster. So even if one data node goes down, you have 2 copies of the data in a different cluster. So you don't need to have separate backups. And we referred to that. We actually called this out in the presentation as well, where we said you have to think of Hadoop backups slightly differently from RDBMS backups. There might be cases where you want to use a replica cluster in case you want to use the same data set for both for your dev and the QA instance and production instance and so forth. But apart from that, from a data resiliency perspective, you need not. So I think I have covered most of the questions that how to choose between Hadoop and Apache Spark. What are the factors to choose between these two? If you want near real time and you have the resources to afford high high memory, I would say a superior hardware that is more conducive for in-memory analytics, Spark is the way to go because as compared to MapReduce, Spark is much faster. And also, right, the Spark, in addition to the actual data processing methodology, Spark has also got built-in libraries, machine language, Spark mlib and graphics. So if you have a use case that would be satisfied out of the box with one of the Spark APIs, Spark might be the way to go instead of custom coding the same algorithms or the same logic in MapReduce. So that concludes most of the questions as well. Could Hadoop replace my EDW? I just got that question. Potentially the answer is yes. It can, we believe at Rackspace, we've seen customers that completely unplug EDW and move on to Hadoop. The cost per terabyte or per gigabyte is cheaper. On the tooling, from an end user perspective, most of the popular tools, ETL and visualization tools, are available and supported out of the box. So that covers most of the questions as well and the presentation. And thank you so much for your participation. And I would really appreciate it on behalf of my colleagues at Rackspace if you could take a few minutes to rate the presentation. And we'll be more than happy to. We also, encourage you to visit the Rackspace Manage Big Data page, the Rackspace Big Data website that is available on the attached PDF presentation. And any questions you have or any follow-ups that you need and any help you need on implementing Hadoop, we'd be more than happy to talk to you. Feel free to call your Rackspace account manager, or feel free to email me, and we'll do what we can to help you. Thank you so much, and I think we have about 4 more minutes, and please continue with the ratings, and please continue with any questions you have. So I'll be more than happy to answer them as they come in. Okay, one question just came. Can you please elaborate on DR and replication? So DR, right, typically a quick scenario for DR would essentially be something called replica cluster. So you would create a smaller cluster, and there are out-of-the-box utilities. One of them is called DisCP, right? It's a core Hadoop API. So essentially DisCP, as and when a checkpoint and a commit happens on the primary cluster, DisCP replicates the data over to the replica cluster. And then there is something called HDFS snapshot that lets you snapshot a point-in-time timestamp on the replicated cluster. So you have the data that is more or less in sync with the primary cluster, but at the same time you can go back in time to a point in time in which the snapshot was taken. And also the next question was, what is the best tool for machine learning and data analytics? Our preference, right, if your machine learning APIs are available in Spark MLib, that would be the easiest way to go, because Spark offers you a very good alternative to MapReduce. There are pre-built APIs that let you work off of the HDFS data, and it becomes it's a single API, both from an application development and from a data processing perspective itself. Why is Rackspace not doing as much with Hadoop as IBM AWS? Because Rackspace, right, our model is support. Our model is support. We are not necessarily into software development on the Hadoop side. We just implement software that Hortonworks builds. So that way, it's we are more. I mean, our secret sauce is support around Hadoop, not so much software development around Hadoop. So thanks again, everybody, and thanks all for joining. And I look forward to any feedback or any emails, and you can look forward to being in touch with all of you. Thank you very much.